So if I impose the same conditions, what happens to dg? Okay, what was the criterion for spontaneity? dg at some conditions less than equal to 0. Put the same thing over there and you get dg is equal to plus mu b dnb plus yes. What is that equal to? Huh? Right. That is what we saw. The change in Gibbs free energy at constant pressure and temperature was equal to the maximum additional work. So this entire thing is essentially your W additional maximum. Well, of course, this has to be negative, yeah? Work has to be done by the system. The Gibbs free energy has to be minimized. Think of a two component system, A going to B, right? So the number of moles of A decreases, the number of moles of B increases, and then you have to, well, actually the number of, if there is no stoichiometry, or it's equal to 1 or it's equal, that the number of moles of A that decreases should be equal to the number of moles of B that is increased. So what you have is the difference between the chemical potentials of A and B, mu A minus mu A plus mu B. Right? And if mu B is lower, only then the process will be spontaneous. Now think of some examples. So this is not expansion work, all of this. This is work additional. Right? So the example which I could give you very easily is an electrochemical cell. Think of electroplating. You take some gold solution and you start depositing gold on one of these electrodes. So the chemical potential of gold on the electrodes plus whatever the electrons are in gold. So if I add up all that, the chemical potential of that particular thing has to be much lower. I am doing an electrical work on top of it. I am supplying some potential. Yeah. So that is the additional work. It's not an expansion work. So the number of moles are transferred from the solution to the plate, to the electrode. What more can I tell about this fellow? The chemical potential. It's not just limited to the Gibbs free energy. Okay. If you realize, you can actually write it in terms of anything. U, the internal energy enthalpy, or your Helmholtz free energy, and that should be fairly easy, realizing that dg is equal to dh minus tds minus sdd, and which is equal to du plus pdv plus vdp minus tds minus sdt, right? And if I write the expression for dg from above, then it is vdp minus sdt plus sigma j mu j b of nj is equal to this entire thing on top plus vdp minus tds minus sdt, and I can cancel this and this. I can cancel vdp with vdp. All I am left with is du is equal to pds minus pdv plus sigma j mu j d and j, right? So if I hold the entropy, volume, and all of these constant, all the dnj's equal to 0 except for one of them, let me call it k. So except for k, I hold all of them constant. I just change k, or du, sorry. So then what I have is change in u with respect to the change in number of moles of component k at constant entropy, volume, and rest all these components fixed is nothing but it's the chemical potential of K. Likewise, you can continue and see that the chemical potential can also be defined as, let me use K itself. These are just dummy indices, so I can use anything. That's not a problem. I, J, K, anything. So this should be the natural variables were volume and temperature. So if you want, you can derive. And that should be equal to mu K, should also be equal to enthalpy divided by change in component K, and that was entropy, pressure, and the rest of the components fixed. So if I define the chemical potential, I have defined essentially the change in all the thermodynamic functions. Yes? It's not just limited to the Gibbs free energy, though we will talk in terms of the Gibbs free energy because of obvious reasons. Okay. Now there's something which I find very obvious, but still I will tell you. That's known as the Gibbs-Duhem equation. But it has very interesting consequences. And that is, if you see that the Gibbs free energy is equal to mu A N A plus mu B N B, right? And we already know what is dG. That's mu A dNA plus mu B dNB. But then I'll say, okay, to be complete, I must also add, by definition it is mu A dNA plus mu B dNB. Right? Think about the volume if you want to get that intuitive feeling. Think about the change in volume. With Gibbs free energy, I don't think you'll be able to get that intuitive feeling very easily. So dG, I already know it is this fellow, mu A dNA plus mu B dNB. I have to account for the change. So it's a two component system to start with. But to be complete mathematically, I'll write NA d mu A plus NB d mu B. So I should account for all the changes. And because I know that dG is equal to this first two terms, which means that NA d mu A is equal to plus NB d mu B is equal to 0, so is equal to minus of NB d mu B. Okay. Now, this is not just for the Gibbs free energy, it will be for any of these partial molar quantities. And if you wish to again see that intuitively, all you have to do is go back to the graph that I have been showing you. And if you realize in this graph, at any point of time, wherever the partial molar volume of water increases, the partial molar volume of ethanol decreases. And